So for this example, when we try to integrate ln x to the power 3 over x, we could try to do u substitution, where ln x is equal to u, and when we take the derivative, it is 1 over x. Let's rearrange everything, where it is x times du equals dx. And now we can replace the dx in the integral. So we have the integral of u to the power of x over x, and then we have x du, and we see the x's cancel out. And now we just have to integrate for u to the power of 3. So this is essentially u to the power 4 over 4 plus c, which is equal to ln x to the power of 4 over 4 plus c. And here is our final answer. In our next example, we have sine 2x cubed times cosine 2x. So to integrate this, we have to use u substitution again. And let's try to set u equals to sine 2x. And let's take the derivative of that, which is simply 2 times cos 2x. And then let's rearrange everything, where we have du over 2 cos 2x, which is equal to dx. And now let's substitute everything. So we have u cubed times cosine 2x du over 2 cos 2x. You see the cos 2x cancel out, and now we're left with u cubed over 2 du. And the integral of this would be u to the power 4 over 4 times 1 over 2 plus the constant c. And this simplifies to, so over 8 plus c, and then u to the power of 4 is equal to sine 2x to the power of 4. And here is our final answer. In our next example, we have to integrate tan x. And looking at this, it is pretty challenging to see where to start. But remember, tan x is actually equal to sine x over cosine x. And this is a bit easier to work with. So let's try to take u equals cosine x. And the derivative of that is equal to minus sine x, which can be rearranged as du over sine x, which is equal to dx. So now let's substitute everything. So sine x over u, and then du over minus sine x. And you can see that the sine x's cancel out now, which means we're left with the integral of minus 1 over u. And remember, the integral of 1 over u is equal to ln absolute value u, and don't forget the negative sign, and plus e. So now let's just substitute everything. So we have ln absolute value, and then u is equal to cosine x, and then plus e. And this is our final answer. But just note that this could also be written as ln absolute value secant x plus c. I'll leave this as an exercise for you to show why these two are equivalent, but this is our final answer, and either one of these is acceptable. In our next example, we have 2x plus 1 times e to the x squared plus x. So let's try to take u equals x squared plus x, and the derivative is equal to 2x plus 1. Let's rearrange everything. du over 2x plus 1, which is equal to dx. And let's substitute everything. So the integral of 2x plus 1 times e to the u, and then du over 2x plus 1. This cancels out nicely, and then we're left with the integral of e to the u du, and we know that the integral of e to the u is e to the u plus c, and after substituting everything, or just substituting u, we have e to the x squared plus x plus c. And here will be our final answer. If you found this video helpful, please leave a like and subscribe. Thank you for watching.